Hey, it's Dr. Gold again. Here we are in the chapter 6 on annuity payments. And as I said at the end of the first video that I did on this chapter, this type of work begins to get closer to reality because it begins to talk about issues that maybe we're a little bit more familiar with. So in the first video, we went over this process of saving for college. And how much $5,000 payments over a 5-year period of time, what that would amount to, and we went through that process and came up with $28,185. Here we're moving on to a different type of ordinary annuity question. Instead of solving for the future value of an annuity, we're solving for the payment. What are the equal payment amounts going to be that we need to make? So let's just read this question real quickly. Suppose you plan to get a $6,000 car loan at 15% annual interest with annual payments that you will pay off over 4 years. What will your annual payments be on this loan? So here we're going to begin to deal with a question that many of you in the class have probably thought about or actually engaged in, is figuring out payments on car loans. And if you've ever wondered like how banks come up with what that monthly dollar amount is that we pay, or why in the case of, say, mortgages, when a mortgage is just starting out, why a large proportion of our monthly payments early on in a mortgage are mostly interest payments and very little goes toward the principal or amount we borrowed. You'll understand why in a moment. But first, like with all our problems, we have to go through the 5 criteria of the time value of money and sort of help us to map out a strategy for solving the question. So the present value is $6,000. That's a positive number even though it's a bank loan, because it's a cash flow into our lives. We're receiving $6,000 to purchase the automobile. The future value is unknown because it's not really relevant to this particular question. We're not being asked to solve for that. The interest rate is 15%. And the payment, we don't know. This is what we want to know. What will our annual payments be? And just pause this video for a second and think intuitively about this question. And the periods are 4 years as specified in the question. Pause the video right now and think to yourself, will the payment amount be reflected on our calculators as a positive or negative number? And think about why that would be the case. All right, so you should have hopefully thought about the question I just posed. Will the payment amount be a positive or negative number, and why? And let's see if you were right. Here's the answer to the question. I don't know if you can see the entire thing on the bottom, but for n, you would type in 4 for the number of periods, in this case 4 years. For I, the rate of interest is 15%. The present value is $6,000. Payment you'd leave alone initially when you're first entering your numbers into your calculator, and future value you'd put a 0 there. And when you solve for payment, I don't know if you can see it, but it says negative $2,101.59. Now, why is it a negative? Of course, because that's a cash outflow. Every time you make the payment, it's leaving your home, your bank, it's going to another bank or the car auto loan company, the financing company. So the payment amount will show up as a negative amount on your calculator. As you work through, and I'm just going to correct this slide so we can see it a little bit better. Let me just raise this up and then raise that up so we can see it better. Okay, that's better. As we work through this question, we can then place the information from our calculator onto a table. This is called an amortization loan schedule, and I think it helps us to understand why a lot of what we're paying early on in loans can be largely interest and not as much principal, but as the loan matures, there's less of the monthly payment that goes toward interest and more toward principal. Well, first of all, let's look at what we're viewing here. We start out here in year 1 with a $6,000 loan from the banks. That's a cash inflow. And we know that we're going to make 4 equal payments of $2,101.59 based upon our calculations. The third column is the amount of the $2,101 that's interest. Now, how do we know it's $900 in interest? Well, if you take 15%, which is the annual rate that we're being charged by the bank, and you multiply that by 6,000, so 6,000 times 0.15, you get $900 in interest. And if you deduct $900 in interest from our annual payment or annuity payment that we're making on the car loan, that means that $900 will go toward interest, and $1,201.59 that you see here in column 4 goes toward paying off the loan amount, the principal amount of the $6,000. If you then take the amount that we paid off, the $1,201.59, and deduct it from our original balance of $6,000, you're left with, at the end of the first period or first year, a balance of $4,798.41. That carries over to the beginning of the second year, and we go through the process again. Again, you take 15% of $4,798.41, and you get interest, which is a little bit less than the first year, of $719. You deduct that from your payment, so now you're paying a little bit more toward principal in year 2, $1,381. And then that $1,381 again gets subtracted from the beginning balance at the beginning of year 2 of $4,798.41, and that leaves us with a balance you see here in the 5th column. That ending balance for period 2 or year 2 then gets carried over to the beginning of year 3. You then multiply 34,1658 by 15% again. You come up with this number here, 512.49, and you work through the entire process again for year number 3. You'll notice that the interest payments are coming down gradually during years 1, 2, and 3. And you'll notice that the amount going toward your principal balance, or the amount owed on the loan, are increasing over those years as well. In the final year, you'll see that you have a balance here of $1,827.48, and then an annuity payment that's greater than that amount. That kind of confuses students initially, because they're like, well, gosh, why do we have to pay more than what's left on the loan? And the answer, of course, is that this entire amount of your payment does not go toward principal. You still have to pay interest on that in the final year. So if you take $1,827.48 and multiply that by 0.15, you'll get your interest payment for the final year, which is $274.12. And when you subtract $274.12 from your consistent annuity payment of $2,101.59, you're left with a repayment of the principal balance of $1,827, which brings your overall balance to 0. So that's solving for payment on an ordinary annuity. And it also sort of dives into this concept of the loan amortization schedule, and how loan payments are calculated, and then how interest and principal payments are broken down year after year, leading to the final payoff of the loan. And that concludes this video.